Section 1. What is matter? Pure substances and mixtures. Everything around us is made of matter. Matter is anything that takes up space and has weight. Your computer, your lunch, even the air we breathe are all examples of matter. But did you know that matter can be classified into two main types? These are pure substances and mixtures. Pure substances are made up of only one kind of particle. They have a fixed composition, which means they always have the same properties throughout. Think of pure water. It's always made of two hydrogen atoms and one oxygen atom. H2O mixtures, on the other hand, are formed when two or more substances combine physically. Unlike pure substances, the composition of mixtures can vary. For example, you can mix salt and pepper in any proportion you like. Understanding the difference between pure substances and mixtures is essential in chemistry. It helps us understand the properties of materials and how they interact with one another. Section 2. Pure substances, elements and compounds. Let's dive deeper into the world of pure substances. Pure substances can be further divided into two categories, elements and compounds. Elements are the simplest form of pure substances. They cannot be broken down into simpler substances by any chemical means. Think of gold, Ao, or oxygen, O2. They are made up of only one type of atom. Compounds are formed when two or more elements combine chemically in a fixed ratio. Water, H2O, is a great example. It's formed by the chemical combination of two hydrogen atoms and one oxygen atom. Table salt, which is sodium chloride, NaCl, is another example of a compound. Understanding elements and compounds is crucial in chemistry. It helps us comprehend the building blocks of matter and how they interact to form the world around us. Section 3. Exploring the elements, metals, non-metals and metalloids. Elements are diverse. They come in all sorts of properties. To make sense of this variety, we classify elements into three main categories: metals, non-metals and metalloids. Metals are typically shiny, malleable, which means they can be hammered into sheets, and ductile, meaning they can be drawn into wires. They are also good conductors of heat and electricity. Think of iron, Fe or copper Q. Non-metals, on the other hand, are typically dull, brittle and poor conductors of heat and electricity. Oxygen, O, and sulfur, S, are good examples of non-metals. Metalloids have properties that are intermediate between metals and non-metals. They often have a metallic appearance but can be brittle. Silicon, Si, and germanium, Ge, are classic examples of metalloids. This classification system helps us understand the behavior of elements and predict their properties, which is super helpful in fields like material science and engineering. Section 4. Mixing things up. Homogeneous and heterogeneous mixtures. Mixtures, remember, are formed when two or more substances combine physically. But did you know that there are different types of mixtures? We can classify them into two main categories: homogeneous and heterogeneous mixtures. Homogeneous mixtures are uniform throughout, meaning the composition is the same in every part of the mixture. Think of salt water. You can't see the individual salt particles in the water. Air is another example of a homogeneous mixture. Heterogeneous mixtures, on the other hand, are not uniform throughout. You can see the different components of the mixture. A salad is a perfect example. You can easily distinguish the lettuce, tomatoes, and cucumbers. Understanding the difference between homogeneous and heterogeneous mixtures is important in everyday life. It helps us identify different types of materials and understand their properties. Section 5. Separating the components. Techniques for mixture separation. Since the components of a mixture retain their individual properties, we can use these properties to separate them. There are several methods for separating mixtures, and the best method depends on the type of mixture and the properties of its components. Filtration is used to separate a solid from a liquid in a heterogeneous mixture. Think of making coffee. The filter paper separates the coffee grounds from the liquid coffee. Evaporation is used to separate a dissolved solid from a liquid in a homogeneous mixture. If you leave salt water out in the sun, the water will evaporate, leaving behind the salt crystals. Distillation is used to separate two liquids with different boiling points. This is how we get pure water from seawater. These separation techniques are used in various industries, from purifying water to extracting valuable metals from ores. Section 6. Matter's transformations, physical and chemical changes and their significance. Matter is not static, it can undergo changes. These changes can be classified into two main categories: physical changes and chemical changes. Physical changes are changes in the form or appearance of matter, but not in its chemical composition. Melting ice is a physical change. The water changes state from solid to liquid, but it's still water, H2O. Chemical changes, on the other hand, result in the formation of new substances with different properties. Burning wood is a chemical change. The wood reacts with oxygen to produce ash, carbon dioxide, and water vapor. Understanding the difference between physical and chemical changes is crucial. It helps us understand how matter interacts and transforms in the world around us.